Okay, so this is chapter 10.1 to 10.3 mechanics. I'm gonna try and fly through them. We've got 3 pages, but some are long questions, some are very short. So let's start. The diagram below shows two forces, F1 and F2. Determine the signs of the torques due to F1 and F2. What is torque? Torque is another word for moment. And what's moment? It's the turning effect of a force. And it's defined by F times the perpendicular, right? Or you could say FD sine theta. All right, whichever you prefer. Now, torque has its another symbol, which is tau, and it's this weird T. That's pretty much it. The rest you all know. You should know that a counterclockwise rotation is positive and a clockwise rotation is negative. So let's see, F1, when it turns it, how's it gonna go? It's gonna go like this. Okay, so that is clockwise, right? That's a clockwise rotation, and clockwise is negative, positive, negative. So F1 is negative. All right, and F2, and you can put clockwise in brackets. All right, F2 goes like this, right? So it goes like this, it goes up, so that is a counterclockwise rotation. So F2 is positive, counterclockwise. All right, let's just check on the answer real quick. F1 is negative and 2 is positive. Type. A rod is pivoted about its center. Two forces, each of magnitude 5, act at 4 and 2 from the pivot. What is the net torque about the pivot? Yeah, let's start. Over here we have, let's start with, let's call this F1 and we're gonna call this F2. Let's find the net torque. We need to find the total, T1 plus T2, right? Let's find torque 1. So F1 over here is obviously gonna go like this, right? It's gonna pull it like this, which makes it counterclockwise, right? So it's positive. Okay, let's take a look. The force is 5 newtons. The distance is 2 meters, right? Now, what is the angle in between it? Over here, we have 30 degrees. So we're gonna multiply it by sine 30. We're gonna get the torque 1 is equal to 5 Newton meter. Very simple. Okay. Now, torque 2, it's gonna go like this. So that is also counterclockwise, as you can see. So it's gonna be positive. The force is 5, and again, no, first, before I do the angle, I'm gonna do the distance. Force times distance, the distance is 4. The angle is 30, so sine 30. So you're gonna get 10 Newton meter. Adding 5 and 10, you get 15 Newton meter as your net torque. Okay, so you get 15 Newton meter. Very easy, and it's just the formula. The torque, or tau, moment, whatever, is FD sine theta. Okay, now some people solve it differently. If you want to find the perpendicular distance between this force and the pivot, it would be this here, and this angle would be 30. So to find this distance over here, wait, what? Not like this. It's, hold up. Yeah, if you were to do it using the formula, moment is equal to FD perpendicular. The calculation wise is the same, but if you want to visualize it, this is how it would look. This is the perpendicular distance here, so the length of this would be the distance you would use. Okay, now this is just a right angle triangle. The angle here is 30. You have the hypotenuse, so you do opposite over hypotenuse and you figure out what d perpendicular is. And when you do that, you're gonna get that d perpendicular is equal to 2 sine 30, which is the same as what we did when we solved originally by doing f times d times sine alpha, or sine theta, whatever. Okay, same thing. I think moments everybody is comfortable with. Okay, the diagram below shows 3 forces applied at points A, B, and C. At which of the points is the greatest torque with respect to O produced? Now, for question 3, to find which one has the greatest torque, it's honestly very easy. Now, ideally, like, you know, for someone who's just looking at it, you would say this one, F over 2, produces the greatest torque because it's furthest away. But to stay on the safe side, find the torque of each force, okay? So F and L over 4, these are all perpendicular, so you don't need to multiply by any angle. So quickly, F times L over 4, you get FL over 4. Over here, minus F over 4 times L over 2, you're gonna get minus FL over 8. Then you're gonna get F over 2 times L is FL over 2. So obviously the greatest torque is point C. Okay, very easy. Negative doesn't matter, we're taking the magnitude. Okay, I don't care. I'm just looking at the magnitude. Okay, so let's take a look. Is that true? So C is the greatest. 4. What 3 factors affect the torque created by a force relative to a specific pivot point, and how is the direction determined? So what are the 3 things that affect the torque? Now, what is torque equal to? Torque is equal to FD sine theta, right? So what are the oh my god, what are the 3 what are the 3 factors that affect the torque? The force, the distance from the pivot, and well, the angle between, you know, yeah, type shit, you know, the angle of the force. There you go. And how do you determine it? You use this rule. You never use it in your exam or when you're solving, but you just need to know that you can use the right hand rule. Okay, and since it's a grid, you gotta know that. Okay, so this, you gotta know all this. It will probably come multiple choice. A uniform ball, spherical ball, of mass 300 and diameter half meter is resting on a horizontal surface in a vertical plane. A force F of magnitude 6.2 is applied on the ball tangent to one of its extremities. Neglecting friction, what is the resultant net torque acting on the ball about a diameter of the ball perpendicular to the plane of the figure? And then deduce the angular acceleration. So when they say choose, they said choose what's it called? Choose about the diameter of the ball perpendicular to the plane of the figure. So it's a ball, and you guys know there's so many diameters in the ball. There's infinite diameters because it's a sphere. You can go in any direction. So when they say perpendicular to the plane of the figure, this is the plane of the figure here. Okay, this is our plane of the figure, right? This is our plane. Okay, if we want to go perpendicular to it, that means we're gonna go through it. Okay, so kind of like this. Okay, through that middle point. Okay, anyways, so that doesn't really matter. Okay, so we're going to choose basically over here. This is our axis of rotation, and it goes out like this. Okay, anyway, so what are the 3 forces we have on our sphere here? We have the force, and obviously we have the weight of the sphere, and we have the reaction force over here, N, or you could say R, it doesn't matter, the normal. Okay, because it's resting on the floor. Now we need to find the torque of each one. So let's find the torque of F. The torque of F is going to be force times the distance. They said it's 6.2. So 6.2 is the force times the distance, which is half of the diameter, right? Half of the diameter. So 0.25. Okay, then the torque of the weight is 0, obviously, because it passes through the line of action. The line of action of the force passes through the axis of rotation. And then the torque of the normal force is also 0, because, again, the line of action passes through the axis. So if you add these all up, you're going to get 6.2 times 0.25, yeah, like they did here, 1.55. Okay, deduce the angular acceleration of the ball. Now, what did we find now? We found that the net torque is 1.55, yeah? Now, this is when I told you back in chapter 9 that you're going to use this when working with torque. Sigma torque is equal to I alpha. Kind of like sigma F was MA, this is now sigma torque is I alpha. Okay, so to find the angular acceleration, that's alpha, we found the torque, and we have the mass of the ball. So do you think we can use sigma torque is equal to I alpha? Of course we can. What's I? It's the moment of inertia. And what's the moment of inertia? It depends on the shape, but for a sphere, what is it? It's a uniform ball. So what does that mean? Is it empty from inside or no? It's uniform. So that means it's not empty, it's solid. So it's going to be the rule for the sphere, which is 2 over 5 mr squared. We have them over here. Okay, this is the uniform solid sphere. 2 over 5 mr squared. Type 2 over 5 mr squared. What's the mass? The mass is 300 grams, so 0.3 kilos. And the radius, do you take the radius or the diameter? You take the radius, okay? So times 0.25 squared. So I said r, so why am I saying diameter? Obviously, it's going to be radius. Okay, 2 over 5 times 0.3. So 0.4 times 0.3. 2 over 5 is the same as 0.4, huh? Times 0.25 squared. You get, let's just say 7.5 times 10 to the negative 3. Okay, so this is my I. We found the torque. We just need to find alpha. So let's just rearrange our equation. Alpha will be the torque over I. So it's going to be 1.55 over the moment of inertia. 7.5 times 10 to the minus 3. So let's do that. 1.55 over our moment of inertia. You get 206.7 rad per second squared. 206.7 rad per second squared. Oh, I did not get that. How is it 124? 1.55 over 2 over 3. Keep 2 over 3. A uniform. Ah, it's a ball. Shit. Okay, sorry. It's a ball. It doesn't matter if it's uniform. It's a ball. Oh, okay. If it's a ball, remember I said for basketballs and any ball, that means a ball. What's a ball? A ball is it's a sphere, and inside of it, it's empty. It's just air. You pump the ball with air, right? So you don't use 2 over 5. You use 2 over 3 for the ball. Yeah, so it will be different. Sorry. So let's go back. Let me edit this. 2 over 3. 2 over 3. You get 0.0125. Okay, and we're gonna change this here to 0.0125. Okay, let's fix it. Over here, 0.0125. You're gonna get 124. Is that correct? Yes, 124. Okay. Question 6. A uniform disk, a thin hoop, and a uniform sphere, all of the same mass and same radius, are free to rotate about a fixed axis passing through the respective centers. Assume the hoop is connected to the rotation axis by light spokes. With the object starting from rest, identical forces are simultaneously applied to the rims. Rank from least to greatest the angular accelerations of these 3 objects. Now, they all have the same mass. They all have the same radius. Okay, so what does the angular acceleration depend on? Like we said now, we said for these forces, when you have a force and you want to find angular acceleration, you should know that sigma torque is equal to I alpha. So over here, the torque is the same. Why? Because they all have the same force and they all have the same distance. Okay, so the torque is the same. So that means we can't really compare the angular acceleration depending on the torque. So the only thing that we can compare the angular acceleration now is the moment of inertia. And as you can see, these are all different shapes. And obviously, if it's a different shape, then it has a different rule for its moment of inertia. So what is the disk? The disk, how is the moment of inertia for a disk is half mr squared. I'm expecting you guys to know them, okay? At this point, خلاص, memorize them. Solid cylinder means disk, by the way, okay? خلاص, you should memorize these. 1, 2, 3, 4, 5, 6. خلاص, you should have them memorized. Okay, here it's hoop is it's an empty sphere, if I'm not wrong. It should be like this. This is a hoop, if I'm not wrong. So it should be mr squared. And then sphere is 2 over 5 mr squared. So over here, which one has the greatest moment of inertia? The greatest moment of inertia is I hoop. We're going to call this 1, 2, and 3. So I2 is the greatest moment of inertia. The second biggest is this one because it's 0.5 mr squared. So we're going to say I1. And then the least greatest is I3. So if they have the same torque, what's alpha equal to? Torque over moment of inertia. So the bigger the moment of inertia, the bigger the number you have to divide by, and therefore alpha will be smaller, right? So obviously, alpha in this case will be bigger for a smaller value of the moment of inertia, right? So over here, if I2 has the greatest moment of inertia, that means alpha 2 will be the smallest acceleration. And since I1 is the middle, it has a middle moment of inertia, that means it will be the middle in the acceleration. And the one with the greatest acceleration will be I3, because it has the smallest moment of inertia. Okay, so it's going to be like this. Moving on now, question 7. For question 7, a mass 6 kilograms is tied to a cord wound around a disk of radius 0.4 meters. Find the moment of inertia of the disk, knowing that the load drops with an acceleration of 4 meters per second squared. So this is a nice one, صراحة. So you have a cord wound around a disk. So to draw this on the side, I'll use red. You have your disk like this, and its radius is, let's say, 0.4 meters. Okay, perfect. So you have the cord is wound around it. Okay, and here you have the cord like this. So when you drop the cord, it has a mass which is 6.0 kg. It drops with an acceleration of 4 meter per second square. So let's take a look at what's happening here. You have أول شيء, you have the weight of the cord and you have the tension pulling it up, right? So that's the first thing you're going to do over here. It's resolve your forces, okay? Your tension and your weight. So we know that it drops with an acceleration of 4 meters per second squared. So let's do sigma Fy is equal to ma, because it accelerates. So since it accelerates down, W minus tension is equal to ma. And we can do that. The net force, W minus T, will be mg, which is 6 times 10, minus the tension, which we're trying to find, equals the mass 6 times 4. Okay, so that means you can get 60 minus T equals 24, and therefore T is equal to 36. Perfect. So we found T is equal to 36 newtons. Now what do we need to do? We will need to find the moment of inertia. So we now found our tension. Now, how can we relate the moment of inertia to forces and any FBD? Like we said, sigma tau is equal to I alpha. Okay, this is how you do it. Now, what is tau? It's the torque. So over here, what is the net torque? The torque would be the moment, right? So what force are we going to use now? Now, I was a bit confused whether or not to use the net force, T minus W. But obviously, now I read the course division solution. You need to take T as the force for the moment. What do I mean? Like, مش نحنا now we're gonna do sigma T is equal to I alpha. Again, we need to find the moment, right? What's the moment? This disc here. What force is acting on this? The weight is acting. It's pulling the rope downwards. But this tension here is acting actually in both ways, right? The rope here and it's going like this, right? On the disc, what forces are acting on the disc, not the rope? On the disc, I only have the tension going upwards, right? Because this, wait. Here, it's this tension that comes from the disc. It comes from the disc. I just wrote it here just so you can kind of see, it's actually coming from the disc. Okay, المهم, so this is the tension. This is the only force acting on the disc. Now, what do I need to do? I want to find the torque. What's the torque? Isn't it force times distance? Moment. What's moment equal to? Force times distance. Moment and torque, same thing. Okay, so I'm just going to say torque from now on. So the torque is equal to force times distance. What's the force of tension? We found it to be 36. So 36 times the distance, which is what? The radius, right? From the center of rotation, 0.4. Okay, and you get... over here you get 14.4 Newton meter. So this sigma tau is 14.4 is equal to I alpha. Now what is alpha? نحنا we have acceleration. We don't have the angular acceleration. We want the we have the normal acceleration, but we need the angular acceleration. How do you relate the angular acceleration to the normal acceleration? Isn't A equal to R alpha? Exactly. So alpha will just be A over R. So it's going to be 4 divided by 0.4. Okay, so I'm going to substitute this alpha now with 4 over 0.4. So 14.4 is equal to I times 4 over 0.4. Okay, so let's do that. 4 divided by 0.4 should be 10. Yeah, so 14.4 divided by 10. You get 1.44. So the moment of inertia I is equal to 1.44. Okay, is that correct? Yes. Okay, so to summarize, you need to do this rule over here. Okay, anytime you have a FBD, and you're gonna see this question definitely in your exam. Okay, the first thing you're gonna want to do is do sigma Fy equals ma. That's the first step. Find your acceleration, right? Find the tension. Okay, it's a rope, and you have the disc here. You need to find the tension T. Okay, that's the first thing. Okay, so after you find your tension, you can find the torque. How do you find the torque? You do tau is equal to F times D. In this case, the distance is the radius, because you're going to see it like this in your exam. After you find your torque, okay, do sigma torque is equal to I alpha, and use alpha as A over R, because A is equal to R alpha, right? So alpha is just A over R. Okay, to find I. 3 steps. Okay. Question 8. Okay, this one I'm gonna skip this, okay, because it's very long and I more than likely it won't come. Okay, so I'm gonna skip this. You can read it on your own if you want, but I'm gonna skip it. Okay, consider an outward machine of made of two blocks of M1 and M2 by attaching a string around a disk of radius r and mass m as shown below. So you have an outward machine, you have the mass 1, mass 2 here, whatever radius r, it rotates. So given M1 is 5, M2 is 7, m is 1, what's m? M is the disk, okay? M is the disk, 1 kilogram. R is 4 centimeters, centimeter, and G is 9.8. By applying Newton's second law for translational and rotational motion, derive an expression for the acceleration of the system to use the value of the system's acceleration. I'm just gonna read over this and see if I think this is gonna come. If it's long, I'm not gonna solve it. I'm gonna skip it because if it's long, I'm telling you it won't come, okay? So this is the solution. If you want to read over this, it's everything's in the solution. Okay, you can read over it. It's very like it explains step by step in the solution. Okay, and is it? Do I think it's gonna come? No, not at all. This is very heavy. You're no way you can get something like this. Okay, um, a solid disk of mass 5 kilograms rolls without sliding along a horizontal plane with a speed of 2 meters per second. Find the kinetic energy of the disk. So what's it doing? It's a disk and it's rolling without sliding. Without sliding, معناتها it doesn't fall down. Okay, so it's rolling, so it's moving and rotating at the same time. So what kinetic energy you have? You have K translational and you have K rotational. What's K translational equal to? Half mv squared. But what's K rotational equal to? Half iw squared. So if you want to find the kinetic energy, we need to find this and this and add them up. Okay, type, let's start. K translational is half mv squared, so it's going to be half times 5 times 2 squared. Okay, so it becomes 10. Type K rotational is how much? Half iw squared. Okay, what is I? If it's a disk, okay, ooh. Yeah. If it's a disk, what's I equal for a disk? It's half mr squared, right? So we're going to replace I with half mr squared. So Kr is equal to half times the mass, sorry, half times I, which is half mr squared. So times half again, times the mass, which is 5 kilograms, times r squared. We don't know what the radius is, so we're gonna keep it as r squared. Okay, times w squared. What's w equal to? They gave us the speed, right? So how can you relate the speed v to w? How? We know v is equal to rw. So if you want to write w, it's gonna be v over r. And if you want it to be squared, it has to be v squared over r squared. Okay, so w squared is gonna be v squared over r squared. Now there you go. R squared and r squared can just cancel. And we know v is 2, so we're gonna replace this v squared with 2 squared. Okay, so there you go. You have half times 5 times 2 squared. You're gonna get 5. So you have 10 joules and 5 joules, which gets you, when you add them, 15 joules. Okay, there you go. Question 11, our last one. A wheel with radius half and mass 4 rolls without friction along an inclined plane 4 meters long that is inclined at an angle of 30 degrees. Okay, determine the moment of inertia of the wheel if the speed of its center of mass at the end of the movement is 5 meters per second and the g is 10 meters per second, 10 meters per second square. Type, you have on your inclined plane 30 degrees. They told us it's about 4 meters long. Yeah, type, you start from here or you go down here. Type, how can you do this? If you're rolling down, we're gonna talk about the conservation of energy. So, when they tell you what is the speed of the center of mass, do you think they're asking for W or V, the angular velocity or the normal speed? They want the speed, okay? W is the rotation. We don't care about that, they're saying center of mass. طيب, هون عندك your ball. You're starting from the top, you're ending at the bottom. It's a classic ME1 equals ME2. Anytime you have anything like this, where you're falling down, changing in height, you can use ME1 equals ME2. طيب, let's start. That means K1 plus U1 equals K2 plus U2. Now we're starting from rest, so that's 0. Okay, I didn't say they start from rest, but it's obvious. And you start, it rolls. Yeah, there you go. It starts at 0. Type, it finishes at the bottom, so we're just gonna say that it ends at 0. So U1 equals K2. What's U1? It's MGH equals K2. Now, since we're rolling and moving, it's K translational plus K rotational. Okay, so MGH, what's the mass? It's 4 times G, which is 10, times the height. Now, this is 4 meters long. The angle here is 30. I need to know the height. Now, it's just a right triangle. You need to find the height, H, if you have the angle alpha and you have the hypotenuse. Okay, I'm going to teach you one trick. Anytime you want to find the height and you have the hypotenuse, the height is always just the hypotenuse times sine of the angle. Now, you can memorize this trick, or if you want, you can do it. يعني عادي, opposite sine alpha equals opposite over hypotenuse, right? Okay, so how would you find the height? You just cross multiply, so it's L sine alpha. Okay, so it always works. Just multiply the length times sine of the angle equals k translation. What's k translation? Half mv squared, right? So half times the mass, which is 4, times the velocity squared. We're trying to find that v. Plus k rotational, half times I times w squared. Now, let's rearrange some stuff, clean it up. Okay, you're gonna get here 80 equals half times 4, we're just gonna make that 2v squared, plus half times iw squared. Okay. Here, we're working with what? A wheel. Okay, a wheel, let's, I don't know. What shape is a wheel? Let's take a look. I'm gonna open the answer here. Now, I is what? What are they trying? Hold up. Ah, exactly. So you don't know what the moment of inertia is. Sorry. We're trying to find the moment of inertia. We don't know what it is, but they told us that the speed is 5 meters per second. Okay, so they actually gave us the speed. Sorry. نحن we're trying to find the moment of inertia. Okay, same working. عادي, nothing changed. Okay, so we're here. Okay, we're trying to find I. Now, we know what V is, so I'm gonna make it 80 is equal to 2 times 5 squared plus half I w squared. So you're gonna get 2 times 5 squared, 50. So 80 is equal to 50 plus half iw squared. Now what we do here is it needs a bit of how can I say it? It needs a bit of concentration. W, نحن we can't solve, we have two unknowns. We have I and W unknown. So I need to make it one unknown, and that should be I. So I need to somehow figure out what this W is. Now, don't we know that V is equal to RW, like we did in question 10? Yes, we do. So okay, that means W is just V over R. So okay, that means W squared is V squared over R squared. Right? Type, okay, what's V, what's R? Do we have them? Yes, we do. We have 5, and we have that the radius is half. So perfect. 4 squared over 0.5 squared. So you're going to get 16 over 0.25, which should be 64. Okay, you get W is equal to 64 rad per second. Okay, so 80 is equal to 50 plus half I times 64. Half and 64 becomes 32. So 32I is equal to 30. So you get I is equal to 30 over 32, which is, let's see, 30 over 32. It's not the answer here. What did I do wrong? Hold up. Sorry. I used the velocity as 4. How did I? It's 5. It should be 4. I don't know why I wrote 4. It should be 5. Okay, sorry. So 5 over 0.5. 5 squared over 0.5 squared. So 25 times 100. So this should be here. Half times 100. So it's gonna be 50. 50I is equal to 30. That means I is 0.6. There you go. Okay, thank you so much for watching, and good luck in your exam.